Salam. Let's start with how can I test the aldehydes and ketones? So suppose that you are in a science lab and I give you different materials, and my question is, which of these is aldehydes or ketones? Put in your mind, the aldehydes and ketones are also called carbonyl compounds. Okay, this is carbonyl compounds. So how can I test the presence of carbonyl compound? Okay, the material that we're gonna use is called 2,4-dinitrophenyl okay, and it has another abbreviation which is 2,4-dinitrophenyl, okay. So let's start with 2,4-dinitrophenyl as a structure. So we're going to use it, let's say draw it like this form, and we have substituents of nitro. Here we have NO2, and here we have NO2, all right, and here we have N. It has hydrogen, and then this N is bonded to another NH2. Okay, so this is the structure of material that we're going to test the carbonyl compound. So let's take any carbonyl compound, like it could be aldehyde or ketone. We don't care. It doesn't matter to me because it will give us the same result. Once you add the carbonyl compound to 2,4-dinitrophenyl, the condensation reaction will take place. The condensation indicates you're removing a water molecule, or let's say removing a molecule from the two molecules so they combine to each other. So we're going to get rid of the water molecule in here. We have 2 hydrogen from here and 1 oxygen from the carbonyl. So what will be the product in this case? We remove the water molecule. This reaction is called condensation. And then what will be the product? All of these are removed. We have water molecule. And then you have to combine them like Liga. Bond here. You have N. Nothing will happen on the other structure of your compound, as we can see. And here we have NO2, here we have NO2, and then, yeah, this is your compound. The formation of this compound, as we can see, gives immediately orange precipitate. And put a very important point in this case, this is precipitate as a result of organic compound. But in the reaction of 2,4-dinitrophenyl, it gives orange precipitate and as a result of the formation of organic compound. If you have orange precipitate, then you have aldehyde or ketone. So, perfect. I can take the aldehyde or ketone as a result of the positive test with 2,4-dinitrophenyl. If we don't have ketone or aldehyde, no change will happen. But is there any test that I can make to distinguish between ketone and aldehyde? The answer is for sure yes, you have. So let's start with the type of test that we can make, or let's say distinguish between aldehydes and ketones. And now it's time to know what is this. Is it aldehyde or ketone? So we have 2 famous tests that we can use, and the first one is called tolerance test. In the tolerance test, you will have, first of all, silver nitrate, okay, that is dissolved in an alkaline solution. Okay, what will happen to silver? Silver appears as Ag+, and the Ag+ here works as oxidizing agent. And as we can see, the oxidizing agents are being reduced, which means the Ag, okay, will gain electron and then will change to Ag solid. So this test is a redox reaction, literally. Okay, so we have tolerance test. We mix the tolerance test with the carbonyl compound. We mix it with carbonyl. We heat it with carbonyl, by the way. Okay, so what will happen to the carbonyl compound? Okay, so suppose that the carbonyl compound is aldehyde, and suppose that it looks like this, and here we have the other group. Once you add the tolerance test, okay, it will be oxidized and will change to carboxylate, C double bond, O, yeah, and here we have negative charge. So it will change as a carboxylate, and it looks like carboxylic acid in here. Okay, so this one here is oxidized, but the silver itself will be reduced. As a result of that, you're doing all of this stuff in a test tube. The reduction of silver ions lead to make a deposition of silver atoms on the walls of the test tube. In this case, you can say your compound is aldehyde. So it gives positive test with aldehyde. Positive test with aldehyde. Okay. And if your carbonyl compound is ketone, then the silver particles are unable to oxidize the ketone. No change in here. No change with ketones. So for Tollens test, it gives a positive test with aldehyde and negative test with ketones. It gives negative test with ketones. The observations that you will have a mirror. Okay? The mirror appears on the walls of the container, or let's say the test tube that you use. And this is a redox reaction. Okay, so let's go to the second type of reactions, or let's say tests that we can use. And this test is called filling test. Okay, the filling test is based on a redox reaction actually. And it has the same principle as silver particles, or let's say silver ions. So the hero that we're going to use today is copper plus 2. The copper plus 2, as we just remember, are blue color, are blue. Okay, so if you just take these blue copper ions, okay, and then apply some warming, okay, so the filling test, as we can see, it's a copper plus 2. We will mix it with the carbonyl compound and then warming it. And if we have aldehyde, okay, the aldehyde will change to carboxylane. It will be oxidized in this case. And the copper plus 2 will change to copper plus 1. And we just remember that the change in color in this case will be from blue to orange or red, from red or orange. So this is a very important point to put in your mind. What is the change in the observation? But if you have ketone, no change will take place, no change will happen. Okay? So these are very important topics. It gives a positive test with aldehydes, both filling test and Tollens test. The Tollens give observation of mirror as a result of deposition of silver particles. For filling test, it's as a result of reduction of copper. Oh, the redox equation for copper, for example, it's copper plus 2. It will gain 1 electron and then it will change to copper plus 1. And these are the observations from blue to red orange. If there is a ketone, no change, it remains blue. Remains blue with ketones.